Welcome to a video on converting between cylindrical and rectangular equations. We just learned that we can use the following equations to convert between rectangular and cylindrical coordinates, and we can use these same equations to convert between rectangular and cylindrical equations. So if you haven't watched the video on cylindrical coordinates, you may want to watch that first. Let's go and take a look at our examples. Here we want to convert the rectangular equation y equals 1, which is a plane as we see here, to cylindrical coordinates, which means we want an equation that contains only r's, thetas, and z's, and not x's and y's. So if we have the equation y equals 1, using this equation here we can replace y with r sine theta. So we have r sine theta is equal to 1. Now typically when we have a cylindrical equation we want to solve it for r. So let's go ahead and divide both sides by sine theta. So r is equal to 1 sine theta, but we can rewrite this to eliminate the fraction as r equals cosecant theta. Remember, sine and cosecant are reciprocals of one another. Let's go and take a look at another example. Here we have the equation in rectangular form x equals y squared, and here we see the graph of the surface. Again, we want to eliminate x's and y's by introducing r's and thetas. So using these two equations here, we can replace x with r cosine theta, and we can replace y with r sine theta. So we have r cosine theta, and then we'd have r sine theta squared for y squared. So we'd have r cosine theta is equal to r squared sine squared theta. Now again, we typically want to solve these equations for r. So if we divide both sides of the equation by one factor of r and then sine squared theta, we'd have an r on the right side of the equation. So this simplifies, We're left with r on the right side. Here the r's simplify out, and we're left with cosine theta over sine squared theta. Now I'm going to go ahead and write this as cosine theta over sine theta, and then we'd have one more factor of sine theta in the denominator. I'm going to write this as 1 over sine theta. Now the reason I'm going to do that is I know that cosine theta over sine theta would be cotangent theta, and again 1 over sine theta would be cosecant theta. So we could rewrite this as r equals cotangent theta cosecant theta. Let's go and take a look at another one. Here we have the graph of z equals x squared plus y squared. We want to convert this to cylindrical form. So the z is okay, but we want to eliminate the x's and y's and replace those with r's and thetas. And I always like to see the surface, so here we have the graph of the surface on the left. Now this one may look like it's going to be a lot of work, but in fact it's actually the easiest one because looking at all of these equations, x squared plus y squared is the same as r squared. So this is the graph of z equals r squared using cylindrical equations. Now let's go ahead and convert some cylindrical equations to rectangular form. So here we have the graph of r equals 2, which is a circular cylinder. When we're doing these conversions, we want to eliminate r's and thetas and replace them with x's and y's. So if we take a look at this equation r equals 2, since we know that r squared is equal to x squared plus y squared, we could square both sides of this equation. That would give us r squared is equal to 4. And now we can replace r squared with x squared plus y squared. And since this equation does not contain r or theta, it is now in rectangular form. Let's go ahead and try another. Here we have r equals 3 cosine theta. Again, we want to eliminate the r and the theta by using these equations here. As in the previous example, if we had an r squared here, that would be helpful, but instead of squaring both sides of the equation, this time we'll multiply both sides by r. So we'd have r squared is equal to 3r cosine theta. And now we can replace r squared with x squared plus y squared. And on the right side we have 3r cosine theta, but r cosine theta is equal to x. So on the right side we just have 3x. Now you might be asking, why did I multiply both sides of the equation by r here, and on the previous example square both sides? And that is going to take some practice to get good at, but if I did square both sides, on the right side I'd have 9 cosine squared theta, and there's no easy substitutions for cosine squared theta, but there is an easy substitution for r cosine theta. So it really comes down to being familiar with all of these equations as we see here. I think we have time for one more example. Here we have theta equals pi over 3, so we want to convert this cylindrical equation to rectangular form. So if we want to introduce x and y and eliminate theta, we're going to have to deal with this equation here where tangent theta is equal to y over x. Well, if theta is equal to pi over 3, this equation will become tangent pi over 3 is equal to y over x. So again, if they give us theta equals pi over 3, we can perform a substitution into this equation here. Now we can determine the function value of tangent pi over 3. This should remind you of a 30, 60, 90 right triangle. Here's the pi over 3 or 60 degree angle. So the ratio of the three sides would be 1 to square root 3. So the tangent of pi over 3 would be square root 3 over 1. So we have the square root 3 over 1 is equal to y over x. And now we can cross multiply. That would give us y must equal square root 3 times x. And this would be the equation in rectangular form. I hope you found these examples helpful. Thank you for watching.